Hi students, today I'm going to talk about the chapter quadrilateral, and within that chapter I'm going to discuss about the three shapes, which is parallelogram, rhombus and trapezium. Now there is something common between all these three shapes, and that is that we have couple of sides parallel to each other, which means in the case of parallelogram, AB is parallel to BC, and the opposite sides AD is parallel to the side BC. This is very important. We are talking about parallel lines in a parallelogram. Similarly, in the rhombus, opposite sides are parallel to each other. AB is parallel to DC and AD is parallel to BC. Coming to the trapezium, the two parallel sides AB and DC are parallel to each other, but the other two opposite sides are not parallel to each other. This is very important. The reason for talking about the parallel lines is that we have studied in class 7 that if there are two parallel lines and there is a traversal line which cuts both of them, then their internal angles, say 1 and 2. So 1 plus 2 is equal to 180 degree. These are the interior angles sum. 1 plus 2 is 180. So this is what we are going to apply in these shapes. Now we have two parallel lines and there is one line which is cutting these two parallel lines. Just observe this very carefully, right? These are two parallel lines and AD is the traversal line. So internal angle 1 and 2, the sum will be 180 degree. Coming to the rhombus, these are two parallel lines. There is one traversal line which is AD. So internal angles, the sum will be 180. So 1 plus 2 will be 180. Similarly, these are two parallel lines and BC is the traversal line just like this. So the internal angle sum, which is 3 and 4, the sum of angle 3 plus angle 4 is 180. Coming to the parallelogram, again, there are two parallel lines and these are the traversal line. So in this case also the internal angle 1 and 2, the sum will be 180. This is, you have to remember because we have already studied parallel line concept in the last class. So this is where I wanted to start. Now going to the other properties of the parallelogram. So one, parallelogram, opposite sides are parallel. We know this now. The opposite sides, if you see, this is equal to this and this is equal to this. All the four sides are not equal. Opposite sides are equal, right? So this is very important. In case of rhombus, all four sides are equal. This is the difference between a parallelogram and the rhombus. In parallelogram, opposite sides are equal. In rhombus, all four sides are equal. Now, let me talk about the parallelogram again. Let me draw the diagonals A, B, and AC. Now, what is happening when I'm drawing the diagonals bisect each other. So AC is bisecting BD, which means if I put the spot as O, then DO is equal to OB. This part is equal to this part, and this part is equal to this part. AO is equal to OC, which means both the diagonals bisect each other. This is very important. Third thing, so I'll just write that diagonals bisect. Second important point is opposite angle A and opposite angle C. Angle A and angle C are equal. And so angle B will be equal to angle D. We should know these properties because there will be a lot of sums which will come on these properties, right? So quickly summarizing, opposite lines are parallel, opposite lines are parallel. Second, the internal angle sum is 180, internal angle sum is 180. Third, the diagonals bisect each other, right? Unlike in rhombus, let me draw the diagonals here. The diagonals again bisect each other, but they bisect at 90 degree, which means AC is perpendicular to BD. AC is perpendicular to BD. This is the difference between a parallelogram and a rhombus. Rest all remain same. Opposite angles are equal in this case also. Angle A is equal to angle C and angle B is equal to angle D. And all these uh, relationships can be proved by simple two parallel lines and the traversal line. Now coming to the trapezium. In trapezium, we just studied that angle 1 plus angle 2 is equal to 180 and angle 3 plus angle 4 is also 180. Now, going by the definition of trapezium, two opposite sides are parallel. That is important. But the other two non-parallel sides, if they are not equal, now I have made this and this non-equal. So this is the definition of a trapezium. But the moment I make the non-parallel sides equal, then it is called isosceles trapezium. Isosceles trapezium has got two base angles also, angle 2 and angle 4, which are equal. So angle 2 is equal to angle 4. Base angle on the bigger parallel side. Similarly, there are base angle on the smaller parallel side, which are denoted by 1 and 3. They are also same. So angle 1 is equal to angle 3. I hope you are understanding, because everything comes down to this. Two parallel lines, traversal lines, we are applying all properties in this and giving you the features of the different shapes. So angle 1 is equal to angle 3. Coming to the diagonals of the trapezium, if we draw the diagonals of isosceles trapezium, they are same in size, which means AC is equal to PT. Right? So just to give a small summary, the first thing which I spoke about these three shapes was that their internal angles, the sum is 180. All of them internal angles will be 180. Their opposite angles in parallelogram and rhombus will be same, right? Their diagonal in parallelogram bisect each other, but they don't fall at 90. They fall at 90 degree in case of rhombus, right? And in the third figure, trapezium, the most important key takeaway is that if it is an isosceles trapezium, which means the non-parallel sides are equal, then their base angles, which on the bigger parallel line 2 and 4 are equal, right? 2 and 4 are equal. And the base angles on the smaller parallel line, which is 1 and 3, they are also equal. I hope I have covered many points on this, but the most important thing which you have to remember are these properties of the parallel line. I hope you could understand this. See you in the next video.